Hi everyone, welcome back to another video, and in this video I'm going to be talking about integration. So in the last video I have already discussed what is differentiation. So if you've not watched that video, what are you even doing? Watch that video, I've made it for you. So I have discussed what is differentiation and the formulas and everything relating to it in the last video, and in this video it's going to be only about integration. Okay, all right, so before starting with it I will just say, what does it mean? I will just ask, what does integration mean? Integration in English means that we are just doing nothing but adding stuff. Okay, there's some numbers, there's some variables, functions. Let's not get into that. We are just going to add stuff. Okay, but again, as I asked this question before as well, I'm going to ask this question again, that if I'm going to add, okay, then why not use summation? Summation is also one of the keys which we can, like calculus is one thing we can use integration, but why not summation, right? The answer being that when we use summation, we are going to add discrete things. For example, I'll give you an example. Let's say we are going to add 1 plus 2 plus 3 plus 4 till n. This is a AP, arithmetic progression, or you as you would say. So this is an AP and we're going to add all these numbers together. I can write this as summation of I from 1 to n. Okay, and that's how we're going to add all these numbers together. These are numbers like 1, 2, 3, 4. They're all discrete numbers and we are going to add this till n. Okay, all right, but let's say I want to add all the numbers that exist between 3 and 4. Okay, 3 and 4 are two numbers. Okay, and all the numbers that exist between 3 and 4. So you can think about like a lot of numbers, right? 3.01 is also a number, 3.1, 3.000001. So we have so infinite number of numbers between 3 and 4 exist, right? So in cases like this, when we don't have discrete things that we want to add up together, okay, in those situations or in those scenarios, we use calculus or we use integration. Okay, is that clear? When do we use integration? When do we use differentiation? Okay, when we have discrete things that we want to add up together, we use summation, which is also one of the most important addition parameters I can say. And let's say we want to add atoms on a surface together. Again, that is not discrete. Okay, there can be plenty of atoms or billions and trillions of atoms on a surface. In situations like that, we use integration. Is it clear? All right, moving on, we need to know now more about what is integration, how do we perform integration, what are the basic formulas that we use. All right, so before getting into that, let's say I have an example. Okay, y is equal to x squared. So y is my dependent variable, whereas x is my independent variable. By that, what I mean to say is, like, x can have any value. It can be 1, 2, 20, 45, whatever, right? But the value of y is going to depend on the value of x. Let's say the value of x is 1. Y is going to be 1 square, which is 1. Okay, let's say the value of x is 2. It's going to be, y is going to be 2 square, which is 4. Okay, so that's what that's what it means when I say dependent and independent variables. Okay, so that's why आपने कभी सुना होगा, it says that y is a function of x. Okay, इंग्लिश में अगर तुम इसको ठीक से सुनो, इसका मतलब यही है कि y depends on x. Okay, y is a function of x is nothing but y depends on x. And how does it depend on x? It's by this relation called x square. Is that clear? Okay, so now in the last video, which I hope you've already seen, we have discussed what is differentiation. Okay, so if I want to differentiate this function y, okay, but with respect to x, what does it become? It becomes d by dx of x square. Okay, and by the very formulas which I already know, it becomes 2x. Differentiation of x square is 2x. Is it clear? Now, by the very definition of integration and differentiation, see, integration means to integrate, which means to club together, which means to add up things, and differentiate means to differentiate, which means to just differentiate the things, right? By the very definition of it, they both are doing just opposite of each other. जो भी integration कर रहा है, उसका उल्टा ही differentiation कर रहा है. Clear? So if x square is differentiating to give 2x, यहाँ पे मैंने differentiation किया और मेरा आंसर 2x आया, तो 2x का integration मेरा x square होना चाहिए. This is what I mean to say when I say that they are opposite to each other. Clear? Now there's a basic formula which is a formula that we use in integration. जैसे हमारा differentiation में था, similarly यहाँ पे we have a very very basic formula. Integration of x की power n dx is x raised to power n plus 1 upon n plus 1 plus c. Now what this c is, okay, I'll discuss in a while because it has to be discussed, but this is the basic formula which we use when we want to integrate stuff. Okay, so as I said, okay, 2x ka integration should be x square. Now let's see whether it is. Okay, so if it's integration of 2x dx, of course 2 is a constant, it will come outside, so it will be x dx. Okay, what will it become? 2 into x ki power 1 plus 1, which is 2, divided by 1 plus 1, which is 2. Okay, it goes cancel and this becomes x square plus c. Okay, ये c तो आना ही है इसको, तो we have to write it no matter what, when we are doing indefinite integration. When we are doing definite integration, that time we will not have to add this c to get c after that. But what is indefinite and indefinite integration? If you know it, then that's great. If you don't, then let's not know it for a while. Okay, अभी के लिए add this c. Okay, just add this c. All right. So इसी formula से if I perform more integrations, integration of x की power 3 dx, it will be x की power 4 upon 4 plus c, because x की power 3 plus 1 divided by 3 plus 1 plus c. Is it clear? Okay, what if we have x की power minus 2 dx? Very simple, x की power minus 2 plus 1 upon minus 2 plus 1 plus c. Alright, this becomes x की power minus 1 upon minus 1 plus c, or we can write it as minus 1 upon x plus c. Is it clear? Abhi tak it's quite simple, it's great going, but what if this happens to us? We have integration of x की power minus 1 dx. We are clear, we know one formula ki yaar whatever it is, we are going to just be adding minus 1 plus 1 upon minus 1 plus 1. It becomes x की power minus 1 plus 1 upon minus 1 plus 1. This becomes x की power 0 upon, oh my god, 0. Okay, and this x की power 0 upon 0 is what? It's not 0, it's not defined. Okay, anything which has a denominator as 0 is not defined. So this value is not defined, and then we are like stuck. Now what to do? Okay, so that's why this rule has a small exception. X की power anything, if n, okay, it's minus 2 plus 3, whatever, is going to be, we are going to use the formula which I just said before. But if it is x की power minus 1 dx, in that case the integration is log x, of course plus c. ठीक है, this is something which you have to remember. ठीक है, x की power minus 1 को you cannot use that formula which I just gave and do the answer, because this is the right integration of x की power minus 1. Okay, all right, moving on, we have if integration of e to the power x dx. So this e to the power x is like the most unaffected person or unimpressed person of all times. E to the power x का तुम integration करो या differentiation करो, the answer is always going to be only e to the power x. It does not change. It does not like to change. Okay, so integration of e to the power x is dx is also e to the power x. Differentiation of e to the power x dx is also equal to e to the power x. Okay, of course here we will be having a plus c also. Okay, so just like this, some formulas which I have given you, these are some formulas which you basically need to remember, because you have to remember, you don't have another option. Okay, so if there's a constant, as I said, differentiation of a constant d by dx of a constant k is equal to 0. I told you aankh band karke just write 0, because differentiation which means a constant has a constant value, it does not change. Okay, so value of change is going to be 0, so differentiation of a constant is always 0. But integration of a constant is what? Let's say we're going to integrate k dx. Okay, now we can just write it as integration of k x की power 0 dx, because if there's nothing, x की power 0 is also 1, right? So we can just write it like this. So k will go outside, it becomes x की power 0 dx. Okay, and by using a simple formula, this is k x की power 0 plus 1, which is 1 upon 1, so it becomes kx, of course the c. Clear? So ऐसे याद करने की ज़रूरत नहीं है कि कैसे निकालना है. Simple formula which I have told you works great, works like magic. And these are some trigonometric functions जिनका तुम्हें याद होना चाहिए, like cos x, sin x, cos x. Okay, all these are the formulas which you need to, I would say, memorize, because it's really required. Next, the last thing which I think we should touch upon also is why this c is being added up all the time. Okay, now as I said, we had this function y is equal to x square. Clear? When we differentiated this, okay, we got the answer as 2x. Is it clear? Let's say my function was x square plus 2. ओके, नॉट जस्ट एक्स स्क्वायर, इट वॉज एक्स स्क्वायर प्लस 2. इसको जब मैं डिफ्रेंशिएट करती हूँ, the answer is going to be 2x plus what? 0. Okay, इसका differentiation is going to be 2x, इसका differentiation is going to be 0 because it's a constant, है ना. Let's say y is equal to x square plus 100. In that case, what happens? Again, the dy by dx is going to be 2x plus 0. Is it clear? So differentiation of x square plus 2 and x square plus 100 is 2x. Okay, integration of 2x is x square. Okay, here as I said, integration differentiation are what? Just the opposite of one another, right? So if differentiation of x square is giving 2x, integration of 2x should be giving x square. In this case, this is correct. Okay, but in this case where y is equal to x square plus 2, okay, here the differentiation is giving 2x, but the integration is giving only x square. It should have given x square plus 2 because my form, what my initial function was, it was x square plus 2, right? But my answer after integration is just x square. Okay, in this case where y is equal to x square plus 100, my differentiation is giving the answer 2x. Okay, and 2x ka integration is giving the answer only x square, whereas it is not x square, it is x square plus 100, right? So that's why, you know, because we don't know whether there was a constant in the initial function or not. In the first function, there is no constant, it is only x square. Okay, so hum yahan pe c lagaye ya na lagaye, it does not matter much. But in the second one and the third one, there are constants, okay, which should have been mentioned, but we don't know whether they are not, whether they are there or not. ठीक है, so instead of taking any chance, हम लोग अपने आप से ही प्लस सी लगा देते हैं. ठीक है, अगर बाय चांस लेट्स से देयर इज नो कांस्टेंट, इस सी की वैल्यू 0 हो जाएगी. ओके, एंड लेट्स से where there is a constant, like in the second case and the third case, here the constant is 2, here the constant is 100. Okay, in that case c will have a value. Is it clear? That's why we always add a c whenever we are performing integration. Is it clear? So I hope this video, in whatever I taught in this video, is clear to you guys, because I will not say that this is a hardcore integration video and whatever are the formulas of integration I have covered in this video, I'll not say that. But having said that, I will also say that this much is quite enough when you are dealing with basic numericals and basic, integration in chemistry. You need, of course, you need a little more, a little higher than this when you go to the higher levels, but as of now you are not at that level. So this much quite works. And if you have any doubts, you can mention it in the comment section. And if you like the video, then you know the drill. You have to like the video and share it with your friends if you think they can get any help out of it. So thank you so much, and stay tuned for the next video.